Okay, so a question from thermal properties of matter. What it is saying that a spectral energy distribution of the sun has a maximum this much. So it has a maximum of this much at wavelength this much, and if the temperature of the sun is this, right, at that time temperature is this. So basically the question is about means wavelength and temperature. So you have to call the Wien's displacement law, and Wien's displacement law says that lambda m into t is equals to constant, right? This is the main matter. Now they are saying about two wavelengths, two different temperatures. They are asking about the temperature of the star when the wavelength is this much. So obviously we need to find out the relationship in either in proportionality or means inversely proportionality. So 1 by t, lambda m is inversely proportional to temperature. So whenever you are putting lambda m1 by lambda m2, then you will get simply t2 by t1. What you will get? T2 by t1. Now put the values, like lambda m1 is for 4753 in angstrom unit. I am not changing because all those are in angstrom unit. You can change, like minus 10 to the power 10 to the power minus 10 meter, you can change, no problem. But why I was saying that I am not changing, because you will get that these two terms will cancel out, right? So no need to change these two. Now is equals to t2 by t1. So when lambda m I am taking lambda m1 suffix 1, when I am taking, then I am putting the value of the wavelength 4753 at which, for which wavelength the temperature corresponding to it was 6050, because it is at the denominator. One suffix is at the denominator. Now t2 you have to find out. So what is the value of t2? T2 will be simply 4753 after cross multiplication 6050 divided by 9506. This is in Kelvin unit. You will get the answer in Kelvin unit. I am not going about the calculation part, but obviously temperature will be less than the previous one, because whenever wavelength is increasing, when wavelength is increasing, obviously temperature should decrease as per this relation. So relation means value will be lower than that value. Okay, maybe it can be cancelled by 2, I think, na? 47 means 94. Yes, you can cancel this by 2. So what will be the answer? 3025 Kelvin is the answer. Okay, so I am getting the actual answer of it. And even see, you can see that this value is less than this value, right? This temperature value, because wavelength is increasing means temperature should fall as per the Wien's displacement law. Okay, so I think you have no doubt in this question, and this kind of questions may ask. I have completed total 20 questions, and one last question I will discuss about the thermal properties of matter in the next video. Okay, so these are all about the means what I say ki all the important questions I have completed from thermal properties of matter. Okay, thank you for watching.